Alright, this is 2.1 definitions. We're going to talk about the difference between class, class limits, versus class boundaries. Alright, in example 1, we were dealing with something that was broken up into classes. Alright, and that really works well for nominal and ordinal level data. But what happens when you start to have something that's on a scale, like height or temperature, alright? Then you have to worry about what happens when you fall in between things. So I have written up two graphs, two number lines with the numbers 1, 2, 3 on it. Now, we might want to talk about, the height of a building. And it might be important to distinguish when I go from floor 1 to floor 2, when do I enter into the next floor? Well, what our book has us do is we make bins, and these are what the class limits are. Alright, so we're on the first floor when we start at the halfway point up to the halfway point in between the first and second floor. After the halfway point at 1.5, we now jump to consider ourselves second floor. Same thing when we go from the second floor to the third floor, that happens at 2.5. When we go from the third floor above, we do that at 3.5. And then similarly, we consider ourselves still on the first floor until we drop below that halfway point. Now, using the halfway point is a real great way of doing things because we are used to rounding things at 5. Above 5, you round up. At 5, below 5, you round down. So you can think about this with our interval notation as you're in it at the halfway point, filled in dot, and you're not in it at the top end of that. And then you'd be in it to not in it to not in it. Right? And this is a great way of doing data, and this is how the book focuses on doing the data. Well, what happened instead of just measuring feet or floors? What if we're measuring something like age? Right? If my kid is 1 versus my kid is 2 versus my kid is 3, how would I then do the class limits, the class boundaries? Well, when I'm doing the boundaries here, my kid is 1 starting exactly at her birthday. And then she's not 1 as soon as we reach 2. Then she's 2, right? Exactly on her birthday. And we do the same thing. We stop before 3 and start up again after 3. So now my class boundaries go from 1 to 2, from 2 to 3, and 3 to 4, as we would continue. I'm just labeling the scale right here. And it's the same deal. On your birthday, you're 1 until your second birthday, in which case you're now 2 until your third birthday, and now you're 3. Alright, this is an alternate way of doing your boundaries. In this case, I'm doing what's known as a floor function. You're not the next amount until you reach it. You can similarly do a ceiling function where as soon as you're bigger than 1, you're always 1. Think about egg cartons here. If you have 13 eggs, how many dozen compartment egg cartons do you need? You need 2 of them because 13 eggs would fill 1 carton plus 1 more. That's an example of ceiling function where you automatically round up to the next one. I don't want to get too hung up on the class boundaries too much. Needless to say, when we talk about classes, think nominal and ordinal. Right? When we talk about class limits, we're talking about the other two, ratio and interval. And in this case, we're talking about numbers where there's a question about, well, where does 1.5 go? Does it go in the 2 or the 3? And I say it depends if you're talking about standard stuff like height and weight. But if you're talking about other things like age, it's kind of up to you. It won't make a big difference when we graph it. Similarly, the class boundaries are really just when you take your information and you're now being picky about where you're at. Are you in 1 at 1.5 or are you in 2 at 1.5?